Thankfully, our campus had ramps. If there weren't any, wheelchair users would have been struggling with all of the stairs.
Yeah, but did you know that they used trigonometry to design the ramp?
Huh? What's trigonometry?
Well, trigonometry is the branch of mathematics studying relationships between a triangle's angles and its sides, particularly in right-angled triangles.
Oh, I see. So that's what trigonometry is. But how do you apply this mathematical concept onto ramps?
Okay, think of the ramp as a right triangle. The vertical height is the door you need to reach, the horizontal ground is the base, and the slanted ramp is the hypotenuse.
Wait, so you're saying the slope of the ramp is actually an angle we can calculate?
Yes, for example, the sine formula is used to find the length of the side opposite one of the angles, and the cosine formula is used to find the length of a side adjacent to one of the angles. The tangent formula is used to find the ratio between the opposite and adjacent sides. How to use this formula? For example, first, label the triangle sides. Second, use Stochastic to help you decide which ratio to use. And the third step is to substitute into the formula, and the final step is to just calculate your answer. See, it's simple as A, B, C. Besides these three basic formulas, there are a lot more trigonometry formulas that also exist. Moreover, the Malaysian Standard Code of Practice on Access for Disabled Persons to Public Buildings even standardized 1:12 slope ratio for ramps. That means if the ramp goes up 1 meter, it should be at least 12 meters long. Trigonometry helps architects check that.
Oh, what an interesting fact. But what would actually happen if the angle of the wheelchair ramp is too steep?
As angle increase, force required to push up the ramp also increases. A shallower ramp requires less force but a longer distance, and a steeper ramp will require more force but a shorter distance. This will increase the likelihood of tipping backwards.
You know what? Next time someone says math is useless, I'll tell them, without trigonometry, wheelchair users wouldn't even be able to enter the building safely.
Well said. Math is really everywhere, especially in the things we take for granted.
You know what else is cool? Sine isn't just about triangles. It's also a circular function too.
Oh, right! From the unit circle. Sine is the y-coordinate. Cosine is the x-coordinate of a point moving around the circle.
Yep, that's why we can use the same sine function for any angle, not just small ones. The ramp is just one example of how that works for angles between 0 degrees and 90 degrees.
That makes sense. Ramps use the triangle view, but the circle definition is what makes sine and cosine valid everywhere.
Exactly. Without circular functions, we couldn't extend trigonometry beyond simple ramps.